Hello people, welcome back. And in today's session, we are going to learn about the MSc. MSc stands for Measurement System Analysis. So what is the measurement system analysis? Say, remember we talk about when they say Six Sigma. Six Sigma is a data-driven methodology for process improvement. And in everything, whenever we make the decision, we rely on the data. How about if your data is not reliable? So, will our decision be reliable? Of course, answer is no. So, what is the guarantee that the data which we are processing to make the business decision is reliable enough? Whenever we have a question that data is not reliable, then we do the measurement system analysis. So, measurement system analysis, basically we are doing the validation of the system. And what is system made of? System made of three things here, which in short we call PPT. PPT is not the PowerPoint presentation. It's made of the pupil, which is operator who is operating, process, which is the method we are following to collect the data, and technology, which means the instrument or machine we are using to collect the data. It will depend on these three things. So whenever we say measurement system analysis, so we are validating the measurement system. Basically, we are trying to validate our pupil, our process, and our technology for the reliability. Are they reliable enough to generate the data which can be used for the decision making? Yes or no. So we validate our operator. We validate our procedure, we validate our machine or the system which we are using to collect that data. So now there are few concepts in measurement system analysis. First, we do the measurement system analysis for the continuous as well as for the attribute data. So you have the continuous data and you have the attribute data. And we have a different rule for that. For the continuous data, we check two important things. Let me just write down here. And those important things for the continuous data is, one is your percent study variation. Percent study variation, always lower is better. And in case your percent study variation is, let's say, less than 10%, then your system is perfect. If your percent study variation is in between 10% to 20%, so you will say your system is acceptable. And if your system percent study variation is coming from 20% to 30%, then system is acceptable, but with some cautions. Maybe your process is critical. You may not accept this much of level of variation. So system is acceptable if it is a normal process. If it is a critical process, we'll say it's not acceptable. And in any case, when the percent study variation is greater than 30%, then it's not acceptable. The rule number 2 for the continuous data is NDC. NDC stands for number of distinct categories. And if your number of distinct categories, which is always higher is better, which means how well your system can differentiate about the part, are they same or are they different? Because two things cannot be same as per the rule of nature. And how well your system can define these two things are different or two parts are different. The high level of accuracy will come as a part of the number of distinct category. So they should be minimum 5 or more than 5 is what we are expecting. These are the two rules for the continuous data. When we talk about the attribute data, Attribute data deal with the three things. One is the accuracy, then repeatability, and then reproducibility. And the label, what we have to achieve, all three things should be greater than 90% for a valid measurement system when we talk about the attribute data. So these are the rules that we follow. Now let us understand some basic concepts here. What is the accuracy? What is the repeatability? What is the reproducibility? And the same thing here, repeatability, reproducibility, and NDCs. So accuracy, if look by definition, that this is the closeness to the target. If I understand in this way, suppose this is your target. Let's say here, this is your target value, and your observation value, suppose you are targeting 90% of the process will meet the accuracy or maybe the productivity. And actually, you are almost at 89%. So you are almost on the target, which means around accurate. As you are making a difference from the target value, that means you are not accurate. This is about the accuracy, which means closeness to the target. When you talk about the repeatability, repeatability means you have the three component of a measurement system: PPT, people, process, and technology. So if your operator, which means the people, is using the same method, there is a no change in the operator, there is a no change in the method, there is no change in the instrument, and there is no change in the part what you are measuring, and you are able to repeat the same result. Suppose first time the measurement result is X. So second time, third time, fourth time, you are giving the result without any deviation or variation, then your repeatability is high, which means you are able to repeat your own result. And when we talk about the reproducibility, so in reproducibility, the value operator will be different. Suppose first time I am measuring something and the second time you are measuring something. So the operator to operator variation or the person to person variation is what change in the reproducibility. Otherwise, rest of the thing remains same. And the sum of the repeatability and reproducibility is called your total study variation, which is also called as an total gauge R and R. Percent study variation or total gauge R and R. R and R stand for repeatability and the reproducibility. This is also called as in total gauge R and R. Now let us understand some more thing, few more thing about this system. What is the bias and what is the accuracy? Accuracy, I explained you. What is the bias and linearity? So the definition of bias is the difference from average value. So you have collected few of the value and you have taken the average of that, and what is the difference from average value to the individual value is called as an bias or also called as in deviation. While the accuracy is almost same, but here instead of taking the difference from average, we take the difference from the target value. The difference from the target, the deviation from the target is called your accuracy. And linearity is consistent bias, which means the difference from the average value is consistent, is called as an bias, or difference from the target value is consistent, that's called as an consistent bias or linearity. So data may be linear or maybe non-linear. So let's calculate something from the example. Let's say here, this is your data and I have generated some random data. Let's say is equal to random between maybe 20 minutes to 30 minutes you are taking to complete a task. Collected maybe for last 5 or 6 data points you have collected. Now if we look at here and see What is my average I will be calculating? Or average value of this data is 25.85, suppose. So first I will just copy paste this data as an value. Now I copy paste this as an value. And now if I look, how much is the deviation from the average of individual value? The difference from average is bias. So bias will be xi minus x bar, which is also deviation as well. So here, this is the bias value. So sometime you are getting the value negative, which is called as a negative bias, and sometime you have the value as in positive. So then this is a positive bias, negative bias, and this is positive bias, right? Now accuracy which means the target. So suppose this is your individual data and the target value of your data is, let's say target that you are looking for on an average as in 25. And these are your values, right? So the bias from the target, which is the accuracy of this data, is the difference from the individual value to the target value. So here we see this is the values are coming. So whenever, please remember, you are comparing with the target, we talk this or we call this as an accuracy. And whenever you are comparing your data with the average value, we call this as an bias. Can be positive or can be negative. This is also the deviation. Deviation can be positive or deviation can be negative. So these are the fundamental of measurement system. Measurement system is very important because we always rely on the data, and to check the reliability we validate our data as a continuous and attribute. This exercise can be skipped in case your system is reliable, the data is reliable, or the source of the data is reliable. In case your data is coming from a reliable source, we can skip this part. If your data, anywhere you have a doubt that your data is not reliable, then definitely we should do the measurement system analysis before we continue the data collection. In next session, I will be explaining you about how to validate the continuous data as well as discrete data. Thank you so much, people. I'll see you in the next session.